Two examples. So the point of this exercise is to try to count how many operations we need to do something. And most of the time we need to define what exactly is that operation, right? So for the first one, we want to find, within an array of n numbers, we want to find which of the first 10 numbers is the largest one. So then if we were to count this, so we want to count the number of comparisons. Now the number of comparisons will always appear within this for loop. So then we're asking about how many operations we need to do within this for loop. Now there is one comparison every time we go in. So then the number of times we have comparisons is the number of times we go inside the for loop. Now this for loop is defined over a range from 1 to 10. Now in Python it means the 1 is inclusive, the 10 is exclusive. So that means how many times do we go inside the loop? You go from 1 to 10, right? So the number of times that you go inside is going to be 9. Now, does it matter what number n is? So if n is larger than 10, if n is 100, how many times do we go in? It's still going to be 9, right? Because we only go from 1 to 10, regardless of what is the length of the array. Now in that case, the number of comparison operations here is always 9, is never any other number for this particular algorithm. Now for the next one, so for the next one here, we are talking about a different problem. So the problem here is about finding the smallest difference between any two numbers in the array. Now, so sometimes when we try to figure out what are the operations we need to keep track of, the problem may give you a hint. So for example, you want to find the smallest difference. Now to find a difference, you know you need to do some kind of subtraction, right? To find the smallest one, you know that you need to do some kind of comparison. Now these are essentially going to be the kind of operations that you will need to do to solve a problem. Now in this case, we are already offered an algorithm, and let's analyze how this algorithm actually runs. Now we want to find the smallest difference. Now the difference here, in this case, we first start with the difference between two numbers, which is the first number a0 and the second number a1. So the abs there is a function to derive the absolute value, meaning regardless of the sign. Now we then go inside here and we go into a loop of I. Now for I, it's going to range from 0 to n minus 1, which means that I is going to go from 0, 1, 2, 3. Now the last number of I is going to be n minus 2. Right? Now we then go into, inside every I, there is a j, right? Now the j here is going to start from I plus 1 all the way to n minus 1. Now if you look at this, right, so let's look at the j. Now suppose that the j itself can run from 0 all the way to, let's say, to n minus 1. Now but because we start from I plus 1, meaning that here there is nothing to do, right? Because here the j is going to start from I plus 1. So when I is 0, the j equals to 0 is not going to happen. So the j equals to 1, 2, 3, 4. That's when we actually do some kind of operations. Now what is the operations we need to do here? So in terms of the number comparison, we are going to do exactly one comparison within every j. So which means that when I equals to 0, the number of times that we're going to go inside the j is going to be n minus 1 time, right? So the number of times we're going to go here is n minus 1 time. Now when I equals to 1, so we start from j equals to I plus 1, so that means we're going to start from 2 onwards. So meaning the number of times we're going to go in is n minus 2. When I equals to 2, we're going to start from I plus 1, which is 3. So the number of times we're going to go in is n minus 3. And so on. Now when n equals to n minus 2, we're going to start from n minus 2 plus 1, which is n minus 1, right? So which means that in the end we only have 1. So essentially then the number of times we're going to go inside the loop is going to be n minus 1 plus n minus 2 plus n minus 3 all the way to 1. So that is going to be the number that we need to do to go inside this loop. Now inside the loop, the number of comparison, you have exactly 1, right? The number of subtraction, you're going to have exactly 1. The number of assignments, you're going to have up to 2. Because you have one assignment here, you have another assignment here. So then if you can characterize the number of times that you go inside the loop, then you probably already know how many comparisons, additions, or subtractions that you usually need to do to solve the problem. Now, what is this number? 1 all the way to n minus 1. So let's suppose that this number is equals to x, right? So what we can do is to write the same number again, but we're going to write it in reverse. Is that equals to x, right? So if we sum them up, so we know that the right hand side is 2x. This one, n minus 1 plus 1. So that's n. N minus 2 plus 2. That's n. N minus 3 plus 3. That's still n. And all the way to the end, 1 plus n minus 1. That's still n, right? Now how many n's are there? So here there are n minus 1 numbers, right? From 1 to n minus 1. So then you have n minus 1 times n is equals to 2x. So then what is x? So n minus 1 times n over 2. So that is the number of times that you're going to need to go inside the loop. Now, so the number of comparisons will be this number. The number of assignments will be twice of this number. The number of subtraction will be this number. Alright?